Your fluid intake can be highly variable, from intaking a lot to intaking very little, but the total volume of fluid in your body usually remains stable. So homeostasis of body fluid volume depends on the kidney's ability to excrete or regulate the amount of water that's lost in the urine. Normally functioning kidneys produce a large amount of dilute urine when your fluid level is high, when you intake a lot of volume, and a very small amount of concentrated urine when fluid intake is low or you have fluid loss. ADH controls whether dilute urine or concentrated urine is going to be formed. So in the absence of ADH, urine is very dilute. However, when you have high levels of ADH, that's going to stimulate reabsorption of more water back into the blood, and that results in a very concentrated urine being formed. When dilute urine is being formed, the osmolarity of the fluid inside the lumen of the tubule increases as it goes down the descending limb of the loop Henle. Remember, the descending limb is very permeable to water, so a lot of water is lost. That means there's more solutes. The osmolarity is increasing. Then the osmolarity decreases as that filtrate flows up the ascending limb because the water's staying in the tubule, and it decreases, not the water, the osmolarity decreases even more as that filtrate flows through the rest of the nephron and into the collecting duct because the water is staying in. Therefore, there's more water forming a very dilute urine. So let's take a quick look at that. So we're filtering across the glomerulus. That filtrate, of course, is then going to pass through the proximal convoluted tubule down the ascending limb of the loop of Henle. Down the descending limb of the loop of Henle. Now remember, this part is very, very permeable to water. So lots and lots and lots of water is leaking out of the tubule. Now, this is increasing the osmolarity because there's less water, and it is increasing the osmolarity because there's less water and more solutes. And then as we come down and turn back up, this fluid is becoming more and more and more concentrated, right? Because we've lost water. And then we move into the ascending limb of the loop of Henle, where we've got transporters that are going to be pumping out sodium and chloride and potassium. And of course, the sodium and potassium are going to move in opposite directions. But if there's not ADH present, not a lot of water, if any, is going to be leaving. So that solute, or the solute concentration, is going to increase as the osmolarity of this fluid is now increasing as well. Because without ADH, the urine is retaining water. So water staying in, water staying in, water staying in through the ascending limb and then into the distal convoluted tubule. The distal convoluted tubule especially has a very, very low permeability to allow water out of the tube if ADH is not. And remember, if it stays in the distal convoluted tubule, it's going to become urine. So if the water is staying in, we're forming a very dilute urine with a very low osmotic pressure. If your water intake is really low or your water loss is high, you're sweating like crazy while you're working out, right? And the kidneys have to conserve water, but they still have to get rid of excess waste products and ions. So under the influence of ADH, the kidneys produce a small volume of very highly concentrated urine. Now remember, the ADH anti-diuretic hormone causes you to produce less urine. That means that more water has to move out of the tubes and be resorbed into the interstitial space and then back into the blood. And the collecting ducts become very permeable to water when ADH is present. So the tubular fluid is losing water back to the spaces so we can keep it in the body, right? Now, when that water moves out of the renal tubules, urea moves with it as well into the interstitial space of the renal medulla, and that promotes even more water moving out of the renal tubule into the interstitial space, because that urea moving with the water into the tissues helps to increase the osmolarity of the tissues, so it sucks out even more water. And the result of all of this is less water is in the urine, therefore it is very highly concentrated.